Okay, my people, what we're going to do here is do two problems about rhombuses, rhombi, and we're going to be finding the area of the rhombus. So first of all, you have to know all the properties of a rhombus, and then let's evaluate what we have in here for this rhombus. I see this angle in here is 60 degrees, which should tell you a lot about the other angles in here. It looks like that'll be 60, and that'll be 60, and this is 60, and therefore, all these are 30 and 30 and 30, and then all of a sudden, you should realize, based upon all of your knowledge of properties of rhombus, that we have lots and lots of congruent 30, 60, 90 triangles. So in order to find the rhombus, we have to kind of use this formula. Diagonal 1 times diagonal 2 divided by 2. So it comes down to knowing the length of this diagonal and the length of this diagonal in here. So those diagonals are longer than the 30, 60, 90 triangles. So let's use our knowledge of the 30, 60, 90 triangles to find these sides in here, and then realize that the properties of a parallelogram and rhombus state that if that side is 24, that's going to be 24. And whatever you find for this little yellow half diagonal, that one's going to be exactly the same in there. So using this formula, we have diagonal 1. We'll just diagonal 1 or diagonal 2. It really doesn't matter which diagonal goes first or last. One of them is going to be 24 times 2, which is 48. And the difficulty of this problem is finding this little mysterious side in here, which is opposite the 30-degree angle. And once we know that, then we can double that to find the entire diagonal, divide by 2, and then we're going to have the area of this rhombus. So your knowledge of the 30, 60, 90 shortcuts have to pop right into your brain. And what happens when we see that the middle side, the side opposite the 60 is 24, and we're trying to get the 30, we should know that we have to divide by radical 3 to go backwards in that shortcut. So when I take 24 divided by radical 3, I have to rationalize the denominator. And what's left? I got 24 radical 3 all over 3, which equates to 8 radical 3. So this side in here, when simplified, is 8 radical 3, which means this portion of the diagonal is 8 radical 3 as well. So altogether, the total length of that yellow diagonal now is 16 radical 3. So what's left in here? Well, we're going to multiply these two diagonals together, and we're going to divide by 2, and let me do that right now and simplify. Let's see, half of 48 is 24, and then I break out my calculator. This is 24 times 16, which is giving us a final answer of 384 radical 3 units squared. So that is the application of some 30, 60, 90 triangles and some properties of a rhombus to calculate the area of that rhombus. Let's do one more here, and this one we're not going to focus on our 30, 60, 90 triangles. This one's going to really focus on using Pythagoras and those properties. So once again, we want to find the area of the rhombus, and what's given about the rhombus is the perimeter is 212. Well, if the perimeter is 212, I'm using my calculator here, it looks like every single side of the rhombus is going to be 53. What other properties do we know about the rhombus? Well, all of these diagonals are going to be perpendicular, and that's always within a rhombus. And then we have one more clue here to apply. The total length of AC in here is 56. So when I see that that's 56, my brain automatically divides it by 2 to deduce that half of that diagonal in blue there, purple, is 28 and 28. And why would I need to know that is because now I see this right triangle, and I know two sides of that right triangle. So when I see two sides of a right triangle, the first thing that comes to my mind is using Pythagoras. So I'm going to call this x, for example. I'm going to go x squared plus 28 squared equals 53 squared. And I believe when you crank that number out, you're going to get 45. Let me just double check right here. 53 times 53 minus 28 squared. And then I take the square root of that number, and that answer is 45, like I said. So this turns out to be a Pythagoras triple. Why is that? Is because all the numbers are whole. That's why it makes it a Pythagoras triple. This is a triple that we don't use very often. This is the 28, 45, 53 triple. And if that's 45, this one is 45 as well. So now we can use that formula. Diagonal 1 times diagonal 2 divided by 2. Or another way of thinking about it is multiplying it by a half. So diagonal 1 looks like it's 56 that was given to us. And diagonal 2 is 90. So when I take my calculator, I do all that arithmetic, and that turns out to be, what number? 2,520 units squared. So hopefully this was a help for you to see there's some skills needed in order to solve for area of a rhombus. We have our shortcuts in the top example, and then we use Pythagoras in our second example. All right? See you soon.